Hello, this video is for the IXL activity titled Identify Functions Vertical Line Test. Its three-character code is Hotel Lima X-ray, and at the time of this recording, this activity can be found at A1.Q.5. Now I got a definition over here on the right of a function. A function is a special relationship in which every input has one and only one output. So every input, also known as the x values, also the domain, and every output, known as the range, but also the y values. So this is saying that a function is a relation in which every x value has only one y value. So we've done identifying functions in a previous activity. This time we're going to do a vertical line test to find out if a relation is indeed also a function. And it's just like it sounds. It's a test using a vertical line. And I have this red vertical line here, and I'm going to grab this vertical line, and how we're going to use this vertical line to test these graphed relations, because I would say functions, but that's the whole point of this, is to determine if they indeed are a function or not. They are relations. We got to check and see if they're functions. So if I take this line here and I start dragging it across this relation here, this graphed relation, right? It's a relation. It's shown on the graph. And as we start pulling it across here, if we can find any place where we can get this line to cross the graph in more than one spot, then it's not going to be a function. So let's find a spot maybe like right here, right? So as I have that spot there, let's go ahead and graph that point there. So right here, there's an intersection. Right there's an intersection of the vertical line and the graph itself. So now pull that away, and we can now see that this value of x, whatever this value of x is right here, I assume 2, it matches up with whatever this value is down here, this y value, and then also this y value here. And I guess I could draw it over to the other side to show that it does indeed go over and match up with two different y values. So whatever this y value is here, we'll call it y1, and whatever this value is here, we'll call it y2. But nonetheless, at this value, assuming that's 2 units over, then whenever x is 2, it has two different y values. And you can see why this vertical line test works so well for that, because the vertical line is actually representing all the different y values. Like right now, this is y is 0. This line shows this line of y equals, or x, sorry. This is the line of where x equals 0. This is the line of x equals 1, equals 2, equals 3. Over here equals -2, equals -4, etc. So you can see why this vertical line works so well in testing a graph to see if it is indeed not only a relation, but a function. A little story about a college class I was in. First day of the class, the professor says, "Who can tell me the definition of a function?" To which a girl in the class quickly raises her hand. Professor calls on her and she says, "It's a function if it passes a line test, a vertical line test." To which the professor says, "Well, that's true, but that is not the definition of a function." And the question of what is the definition of a function that we see here, it was one of the questions on the comprehensive final at the end of that 5 credit hour, 16-week class. So that's why, if you're wondering why do I have that definition of a special relationship in which every input has one and only one output burned into my memory, it's because of Dr. Ewing. All right, let's grab this line here and go ahead and drag it across here on this other one. So let's start dragging it across. It's only one intersection all the way through. And you can see as we go all the way through it, there's only one spot that it intersects. We can't find any place to where the graph intersects that vertical line more than once at a given time. Okay, so in that case, we know that it is indeed a function. Looking at this one here, let's go ahead and get me a line. Grab me a vertical line. There. You're probably already looking at each of them realizing, well, that one is and that one is, but that one's not. Let's go ahead and check it out. This one says, which of these relations is a function? Grab our line here. Well, look, anywhere from here all the way across here, I can find places to where it intersects, sometimes up to 3 times, right? So in that case, we have I think it's going to be almost I guess right there you might have 2 places, and right there, at that very edge, right at the edge of the curve. But all the others, like there's 3 places here, so not a function. We already know a circle's not a function. We've done a circle already. We have this one down here. As we drag across here, um, this would be a parabola, I believe. Yeah, and yeah, it'd be a positive parabola. Get into that further whenever we get into x squared graphing stuff with x to the second power. But as we start dragging it across here, we only see one intersection here. So in that case, we know that this one here is good to go. That's a function. And the others were not. As we grab our line here, good to go up to this point right here. That point we have where we're crossing 2 different ones. So if you can find it anywhere in the graph, it disqualifies it. So that was not a function. We already have the 2 circles up here. We know that we can see plenty of places to where the vertical line intersects the graph more than once. Same thing for the oval. Oval's just like a squished circle, right? So we drag it across there. We can see several places that we would have 2 intersections there. I guess examples are good, right? So like for instance, right here and right here, that's an example of where I guess x is equal to a -1 or 1 unit to the negative side. And pull that away, you can see those 2 points there. It's where x has 2 different y values, so that's no good. So we come down here, well, definitely we can see this one. This is like a parabola on its side, right? So as we drag across here, we have plenty of places to where we have 2 different y values, where, like for instance, where x is, we'll just say +1, right? X is +1. Go on, grab that, there we go. And we could, this point here, and this point here, 2y values whenever x is equal to +1. And that's not what I wanted to do. Try to grab just that line. There we go. Now this one here, you might be wondering, what's this dashed line thing here, right? And this is what is known as, and I'm going to try to pronounce it correctly, asymptote. There we go, asymptote. Good. It's been a while since I said that word, asymptote. Many high school students have funny comments for that word, but we won't go there. Um, so what an asymptote is it is an imaginary line, and it's a line in which another line gets closer and closer and closer and closer to it, but it never actually touches it. Think of this. If we were standing in a room and I told you it was impossible for me to walk from one side, from one wall to the other, you'd say, well, that's not true. So let's think about it. If it's 10 foot wide and I go half the distance, I walk 5 feet. And then whenever I go half of that distance, I walk 2.5 feet. And then whenever I go the distance, 2.5, what is that? 1.1 of a foot. And then I just keep getting closer and closer. I keep taking half and half and half. At some point, I get down to just like, I'm like that close to the wall. And then I take half of that. And it just gets closer and closer. I would never actually touch the wall because if I keep taking half of whatever it is, it's going to be a positive number. We're never going to get to 0. I'm getting closer and closer, but never, ever get to it. And that is what an asymptote is. So this graph is showing that as this line goes up, once we get beyond the graph to where we can't see, as this goes up, this line right here is going to get closer and closer to that imaginary, I need to select my line there, this imaginary line that's right here, this asymptote. This line, as it keeps going up, is going to get closer and closer and closer to this imaginary line. Likewise, as this one keeps going down, it's going to keep getting closer and closer and closer to that imaginary line. Think of 2 cars in traffic, right? One starts merging into the other car and keeps getting closer and closer, but it never actually touches it, but yet it still keeps getting closer and closer. That is an example of an asymptote. So in this case, if it never crosses it, then that means that we realize that at this point right here, that these 2 lines, this line right here, even though it gets closer and closer to that line, it's never going to cross it. And this one here is going to get closer and closer to the line and never cross it. So we know that even though the parts of the graph that we can't see, that these two lines, this one going here and this one going down here, are never going to have the same x value. So therefore, this here is indeed a function. So both of these questions here only had one correct answer. Let's look at what I believe is my final slide here. And I guess I'm going to need another line to do a vertical line test, aren't I? And let's put it right here in the middle. That'll make it easier for me to grab it. And we're going to select all of them that are indeed functions. So, oh, there we go. So I start dragging across all one intersection. It is curvy, but nowhere do I see a point where the graphed relation ever crosses the vertical line, so it's passing the test. So the first one here, that is indeed good to go. It's a function. Looking at the next one here, well, we see right here we got two places we cross, no good. Down here, this looks like a linear function. It's going to be the x to the power of 1, and it's going to be a positive value. The slope will be positive because it's going up from left to right. But as I go all the way across this, no place do I see the line, the vertical line, crossing the relation more than once. So this relation is indeed also a function. The next one we can see is an oval. So we know an oval is not going to pass. We got places where it crosses twice. Up here we have another asymptote situation. So the imaginary line is right here. And this line here, even though it keeps getting closer and closer and closer to the asymptote, and this line here is going to get closer and closer to the asymptote, but neither am I ever going to cross that line or even reach it. So that means the two of them would never cross. So this means that we're good to go on that one. That's going to be a function. And then let me grab my line here. Looks like this parabola is good to go. No, it doesn't cross anywhere more than once. So that one's good. And bring our vertical line down here. Again, another linear function like we saw over on the previous one. But they're both in the lower left-hand corner, both questions. So we see that this one's good to go. That is a function. It passes the vertical line test. And then finally, the squiggly looking thing. This would be something that has two curves in it. So it's going to be something with a variable raised to a third power. Three powers raised to a third power is going to have two curves in it. So that'd be a cubic function. So as we go across here, we see that it does not cross anywhere twice. So indeed, this one is also a function. So on that last one, all four of them are indeed functions. So those are all of my examples for the activity identify functions using a vertical line test. Now, go level up your learning.